Good morning. Today we will continue our discussion in the lesson motion. Prior to this, we have studied about rest, motion, distance, displacement. Using these concepts, we will study a few more topics today. Today we will study about uniform motion, non-uniform motion, speed, velocity and acceleration. So, first of all, we'll study about uniform motion. Uniform motion. The word uniform stands for regularity. Regularity in what? Regularity in traveling distances. Now, whenever any measurement of distance is done, that is always done with respect to time. Like how much distance is covered in how much time. After what interval we are doing this measurement, that may be decided by us. We may choose a larger value for time, or we may choose a smaller value as small as 1 second. So it doesn't really matter after how much duration we are carrying out this measurement. The only condition is that after every single interval, the distance covered by the object should be same. In this manner, the regularity will be maintained, the uniformity will be maintained, and the motion will be called uniform motion. So, how to define uniform motion? If an object travels equal distances in equal interval of time, howsoever small these time intervals may be, the object is said to be in uniform motion. Now, to have a better understanding of uniform motion, let us consider one example. You can see in the adjoining picture, we are having a car that is about to begin its journey and a timer. The timer is presently set at 0. So we will begin our measurement of distance traveled by this car at time equal to 0 seconds. Now after a certain duration, we will check how much distance the car has traveled. Let's begin. So at t equal to 0, x was equal to 0. Now for three different positions, the positions are shown corresponding to time. Very quickly, using any one of these, we can find out how much distance has been covered in how much time. This means the rate at which position of the car has changed. So let's use the first value, for which position is x1 and that is equal to 65.38 meter. What is the time corresponding to it? Time is 4.67 second. The rate at which distance changes with respect to time. So x1 divided by t1, the position, change in position with respect to time, x1 by t1. So that will be 65.38 divided by 4.67. So that will give us 14 meter per second. So this is the rate at which position of the car changes with respect to time. Now if you use any of these three values, at every single value you will get the value 14 meter per second corresponding to the rate at which position changes. So there is a uniformity in which the position of the car is changing. Let's use the second value. x2 is equal to 94.08 meter and t2 is equal to 6.72 seconds. So let's calculate x2 by t2. So that will be equal to 94.08 divided by 6.72. So again you get the answer 14 meter per second. So I hope you have understood that there is a uniformity in the motion of the car. But is it possible that object while covering distances will always show any uniformity? Like say for example, if a car is moving on a very busy road, it is just not possible for that car to cover equal distances in equal intervals of time. Like when there will be less traffic, the car may be covering more distances, and when there is more traffic, the car will be covering less distances. So if we keep a track of the distances traveled by the car after every equal interval, then there will be no uniformity. This means unequal distances will be traveled in equal interval of time. So this sort of a motion is called non-uniform motion. Another example for this will be if an athlete is moving on a racing track. Obviously, the pace of that athlete will keep on changing depending upon the pace of the other athletes. So this sort of a motion is called non-uniform motion. So we can define non-uniform motion as if an object travels unequal distances in equal interval of time, howsoever small these time intervals may be, the object is said to be in non-uniform motion. Now that we have understood uniform and non-uniform motion, so we can next study about speed. Now what is speed? Rate at which position of an object changes. Like in the previous example, we calculated the rate at which position of the object was changing, and that came out to be 14 meter per second. So that is nothing but speed. Speed is the distance traveled by an object per unit time. So you can see the definition. It is the distance an object moves in a certain time. And following the definition, we get the formula. Speed equal to distance by time. It is purely a scalar quantity. Both the terms coming in the formula of speed, distance and time are scalar quantities. So speed is also a scalar quantity. It has got only magnitude and no direction. Now that we have a formula for speed, we can also obtain its unit. So using the formula for speed, we get the unit for speed as meter per second. So this is the SI unit for speed. But if we are measuring large distances, sometimes we make use of another unit for speed. So if the distance is measured in kilometer and the time is measured in hour, then we get another unit of speed as kilometer per hour. So we are having two units, but the standard unit is meter per second. Now a question. If suppose the value you are having with you regarding speed is given in kilometer per hour, and you have to convert it into meter per second, that is the SI unit, then how you are going to do it? We all know that 1 kilometer is equal to how many meters? 1000 meter. And 1 hour is equal to how many minutes? 60 minutes. And then how many seconds make 1 minute? 60. So 1 hour is equal to 60 into 60 seconds. So using this conversion factors, we can convert from kilometer per hour to meter per second. Like for example, if the speed provided to you is 54 kilometer per hour. So for converting from kilometer to meter, you have to multiply by 1000. And for converting from hour to second, you have to use this conversion factor, and accordingly you will get the value in meter per second, isn't it? So let's quickly do the cancellation bit. You can cancel out the zeros. You see, 2 5s are 10, 2 3s are 6. So 54 kilometer per hour into 5 by 18, that will give you the value in meter per second. So how much meter per second you are getting? 18 ones are 18, 18 threes are 54. You get 15 meter per second. So you need to remember that for converting from kilometer per hour to meter per second, you have to multiply by how much? 5 by 18. This is the conversion factor. Now, for considering the distance traveled by an object over a large duration of time, for that, to measure the speed of the object at every equal interval or within small gaps of time is not possible. In those situations, we usually consider the average speed. Now, average speed is calculated by total distance, seeing how much is the total distance traveled and then what is the total time taken. So, average speed is calculated by total distance divided by total time. This is the formula for average speed. Total distance traveled divided by total time taken. Now let us consider one example that how average speed can be calculated. Now just check the position shown on this map. Can you see the red dot? This is the starting position of the object. Now this object is going to move over some distance and we will keep a track of the time taken by this object. Let's begin. See, the object has begun its journey. The time is 7 hours. Now it stops at one position, again begin its journey, and finally it reaches its destination. See, this is the total distance traveled. So you can see the total distance traveled is 502 kilometer. So the distance traveled is 502 kilometer. What is the time taken? Time taken is it begins its journey at 7 hours and it is ending its journey at 13 hours. Now in between it has stopped for half an hour. So the total time taken by the object is 5.5 hours. So let's see how much is the average speed for the object. So the average speed for the object turns out to be 83.67 km per hour. Now even though it had waited for that half an hour, still for covering the total distance it has took those 6 hours. So that comes out to be 83.6 km per hour. So covering the total distance it has took 6 hours and distance traveled is 502 km. So 83.6 km per hour is the average speed. Instantaneous speed. Speed of an object at a particular instant of time. At a particular moment, if you want to find out what is the speed at which any object is moving, that is known as instantaneous speed. From the word instant, we have derived the word instantaneous. At that particular moment, the speed at which the object is moving. Now, this is what actually is measured by the speedometer fixed in any vehicle. So, you all have seen a speedometer. Earlier, we used to have a calibrated scale and the pointer used to show the deflection. It is still existing in many vehicles, but now in some vehicles we also see a digitized version of speedometer. So simply the digits are flashing. So at that particular moment, that is the speed of the object. How we can keep a track of the speedometer? See, following a similar example, once the car starts moving, so anytime we want to check the speed, see, the speedometer is flashing the speed at that particular moment. And one thing you may note that the speedometer measures the speed of the object in which unit? Kilometer per hour. So at that moment the speed is flashing. This is instantaneous speed. Now, if we want to keep a track of the direction in which the object is traveling, like not only the speed of the object, but also how the direction of the object is changing with respect to time, then that is called velocity. Velocity is displacement per unit time. In other words, in simple words, you can say speed with direction is called velocity. Now, since you are including direction, so obviously velocity should be what kind of a quantity? It is a vector quantity. Now, this is one basic difference between speed and velocity. Speed is purely a scalar, while velocity is a vector quantity. Even though both of them carry the same unit, meter per second. Speed and velocity have the same standard units, meter per second. Now, initial velocity, like the velocity when the measurement began, that is denoted by the alphabet u, and final velocity is denoted by the alphabet v. This you should remember. Initial velocity is u and final velocity is v. Now, similarly, if we want to find out the average velocity of any object, then we have to find out the arithmetic mean of initial and final velocities of an object. Now, don't be confused by this term arithmetic mean. It is nothing but average. Arithmetic mean stands for average. And you know how to find out the average of two values? The first value being the initial velocity and the second value being the final velocity. So to find out average of two values, you need to add them and then divide by 2. So this is the formula for average velocity of an object. Initial velocity plus final velocity divided by 2. If you want to find out how the velocity is changing with respect to time, then rate of change in velocity with respect to time is called acceleration. I hope all of you are well aware of this term accelerator. What happens when the accelerator is pressed? The object accelerates. The velocity of the object increases. So acceleration is rate of change in velocity, and again it is a vector quantity. Now change in velocity divided by time. Change in velocity divided by time. That is the formula for acceleration, and the expression, the mathematical expression, you can see it is v minus u divided by t. Now, is it necessary that always the velocity of the object will increase with time? Obviously not. If you are pressing the brakes, instead of pressing the accelerator, you press the brakes, then the velocity of the object will decrease. That is how ultimately we bring any moving object to rest. Say we are riding a bicycle. If we keep on paddling, then the velocity will increase. But if we apply brakes, the cycle will stop. In that case, the acceleration will have a negative value. So, if the velocity decreases with time, acceleration is negative, and negative acceleration is called retardation. Okay, so if velocity decreases with time, acceleration is negative. In this case, final velocity is less than initial velocity, and in this situation the acceleration will assume a negative value. So negative acceleration is called retardation. We'll finish our discussion today at this point, and from next day onwards we will switch over to the numerical part. We will discuss about graphs, graphical representation of data, and also use that graph to solve numerical questions. Thank you.